First of all, quick little review. Pythagorean theorem only works with right triangles. Has to be a right triangle. But it works with every right triangle. Okay? And again, as the rule would be, okay, you will see this in math books. You'll see it right here. Okay? The formula is a squared plus b squared equals c squared. And again, the a's and the b's, ladies and gentlemen, will have to be what? You can't just mix and mingle at any point here. There are certain rules here we have to follow. Alex, the a and the b have to be what we call the
two legs.
The two legs, or the ones that form the right angle. C is the longest side we call the hypotenuse. It is the longest side on a right triangle. It is the side opposite the right angle. Okay? And then we talked about this. In order to be able to do the Pythagorean theorem, you must understand that if you end up with c squared being 8, to go through all this again, Sam, what does c equal?
C equals A.
I help quickly. I thought I did about 1,000
I know.
of these.
Oh, that square root of 8.
Thank you very much.
I can guess.
If c squared equals 90, then c equals, Ava? C equals the square root of 90. Now, granted, these two actually can be simplified, and we'll get to that later on, but for right now, that's good enough. If c squared equals 16, then c equals, Charlie, and in this case, there is a square root of 16, which is 4. Okay, that was all pretty much review. Now, we have what we call these things right here, the Pythagorean triples. Okay, and there is a whole list of them here. As a matter of fact, I'm going to give you this so you can have it in your notes. And what this is, ladies and gentlemen, for only in a certain few triangles does the Pythagorean theorem actually work out to be really nice numbers. Okay? In other words, for the majority of triangles, let's say I have this. This is 3, and this is 5, and I've got this line over here, and I put it in my a squared plus b squared equals c squared. A squared, I do 3 times 3. B, I do 5 times 5. So I get 9 plus 25 equals c squared. 9 plus 25 is 34. And if 34 equals c squared, c equals?
34.
The square root of 34 does not work out to a nice number. It's somewhere just shy of 6. Okay? It doesn't work out nicely. Okay? But if you find your triangle if your triangle has these things, it does work out nicely. This is what you're looking for and hoping for. In other words, excuse me, if you see that a triangle has a 5 here and a 4 here, you don't even have to do any of the math, because the first thing you're going to do is look at your little chart with the Pythagorean triple and say, oh, is there a triple that has 5 for the hypotenuse and 4 for one of the legs? And you go over here and you go, oh, 5 for the hypotenuse, one of the legs is 4, the other leg has to be 3. You don't even have to do any of the math because it works out perfectly. Same thing for this. If you would see a triangle that looks like this, if you see that one leg is 40 and the other one is 9, the first thing you do, before you do this whole long formula, is you go back to your little chart and say, is that one that's going to work out nicely? And oh look, 9, 40, the other side has to be 41. Okay? But those are only a very few, really. When you think about the infinite amount of possibilities that sides of triangles could be, this is just a very few that work out. But fortunately for you, the book is really pretty nice, and usually it gives you ones that work out. If it doesn't work out, you end up with something like this that doesn't work out to a nice number, but you should be able to give a close answer. You should be able to tell me, oh, that's close to 6 or whatever it is. Yes, Howard?
For the test, we have to memorize.
No, I said I'll give you the sheet. I'll let you use sheets all you want on Pythagorean triples. By the way, you certainly should know a 3, 4, 5 triangle because that's about as common as it gets. Okay, you'll hear people talk about 3, 4, 5 triangles all the time. And when they talk about 3, 4, 5 triangles, they're talking about the Pythagorean theorem. They're talking about one side being 3, one side being 4, one side being 5. Kendall,
I don't get how you got the last number.
this one?
No, like yeah, that one.
Okay, I went to my chart, and since these are the two legs, the short side and the medium side, I looked to see if there was a 9 and a 40 on my chart. Here's a 9, here's a 40, maybe you can't see it from where you're at. The hypotenuse will have to be 41. It's just looking at the chart and seeing what number fills in the blank.
So you can do math.
You could do the math if you like, but that's going to take you a long time. I said if you look on the chart and it's there, just use it. I mean, if you want, it's going to look like this though. If you do the math, it's going to look like this, Kendall. A squared plus b squared equals c squared. You'll have to do 9 squared plus 40 squared equals c squared. You'd have to do 81 plus 1600 equals c squared, and then you'd have to get 1681, and then somehow in your mind, you would have to know that the square root of 1681, in fact, is 41, which it is. Okay, so I would check this first before I would sit down and try and do all of this math. That's my thing. Alex?
Do you know who came up with this?
I'm guessing Mr. Pythagorean. Mr. Pythagoras, actually. Look him up sometime, do a nice report on it. Now, with that being said, children, here's where things get just a little bit more exciting. These are not the only Pythagorean triples that actually work. Okay? There are actually a countless, infinite amount of Pythagorean triples. But they come from these base ones. Every Pythagorean triple has an infinite amount of them that would come off it that is proportional to it. In other words, this. If you take every side here and double it and make it 6 and 8, this side would have to be 10. Okay? If you took each of these sides and tripled them, you will get a 9, 12, 15 triangle. Those are all Pythagorean triples too, but they come from this base triangle. It's just, I don't know, doubled or tripled or quadrupled. So it gets a little goofy because you have to be able to think a little bit here. If you would find this case here, see if you'd see this, let me draw this one here. If you find that this is 16 and this is 12, and they ask you for the hypotenuse side there, okay, you're going to look on your triples chart and you're going to see that there is no such thing as a 12, 16 something triangle. Okay, but if there's not, then you have to look at the two numbers you're given and seeing if they have a common number that they could be reduced or divided by. In other words, is there some factor of 12 and 16 that they both have that you could, like reducing a fraction? If you had 12 16ths for your fraction, what number could you reduce that to? What number goes into both of those, Ava?
4.
4. So if you divide this by 4, you're going to end up with a 3. If you divide this by 4, you're going to end up with a 4. And then you would look at that and see if there's a Pythagorean triple, which there is. There's a 3, 4, 5 triangle. But the problem is this side is not 5. Anybody know what I'd have to do to actually find out what the side is? Ashley?
You just double it?
Not double.
Or I mean triple.
Not triple.
Four.
4-pole. if that in fact is a word. In other words, this, if I divided by 4 to get down to this to see my base triangle, to get back from my base triangle back to what the original one, I'd have to re-multiply this by 4 at the end to get to see what my new hypotenuse would be. Okay? So if you reduce it in the end to find it, you have to go back and make it bigger again. Let me give you another example. Let's see. 1630 blank hypotenuse. 1630, I look on my triples chart, I don't see any 16s or 30s, but I look at 16 and 30 and I go, I can take, those both can be divided by what number? What number goes into 16 and 30? So, 2, they can both be cut in half, which gives me an 8 and a 15. I have to then look at that and say, is there an 815 up here? Sure, 815. The other side is 17, but it's not 17 because that's the root triangle, the base triangle. I have to go back and make it bigger, redo what I undid here because I divided by 2 to get back to my original number. I have to multiply by 2. It would have to be 34. So for every triangle here, there's going to be an infinite amount of ones that you can double, triple, quadruple, 10 times, 100 times, whatever times, and find that answer there. Okay? Yes, Alex?
Will the hypotenuse always be bigger than both?
Yes, it has to be. We talked about that before. In a right triangle, the hypotenuse will always have to be bigger than any of the other 2 sides. Okay? Has to be. There's no way around it, just because of the way it is. Always, 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 always. No matter, I mean, look at how close these are. 16, 63, 65 triangle. I mean, those 2 are awful close, but it's never ever going to be that same size. Mostly because if it was that same size, you know, if you were, one way to do that would be to set a compass with your radius being this. And if you set your radius being this, it would become and draw an arc like this. And if your side ended right there, there's no way that this would be a right angle. Okay, as a matter of fact, this would end up being a what type of triangle? An isosceles triangle, which would mean that the opposite angles would be equal, which would mean there's no way they could be 90 degrees because you couldn't have the 2 90-degree angles in a triangle. Okay. Let me give you one. Let's see if you can figure this out. How about this one? We'll go hard right off the bat. Let's go right for the jugular. What if this was 130 inches and this side here was 50 inches? How long would this side have to be if it's a right triangle? You should be done. By the time I came and stood over here to the podium, you should have said, oh yeah, got it. Again, think about what you can reduce them by. There is no 130, there is no 130, no 50s anywhere in that chart, but think about what you can make it smaller by. What can you reduce it by? What number goes into 130 and 50 that you could change it to? I told you I was going tough right off the bat. You are 7th graders, you do have a little, they expect a little high intellect from you here. Nate Cook.
It would be 120.
Nate says 120. Can you tell me, sir, how you ended up with 120?
Because
What did you divide these by?
I divide them by
Okay, which made this a 13 and a 5. And you looked over here to see if there was a hypotenuse of 13 and a short side of 5, which meant the other side had to be a 12. But it's not actually 12. 12 is the base triangle. You have to, if you divide it by 10, you have to then re-multiply by 10 to get back to the actual triangle that you had in the end. It's not an easy thing, but it's not a hard thing either. Kendall?
How is 65?
It's not. It should have been 50.
Oh, well, yeah, I got that.
My bad. Just another example about neatness and accuracy. Alright, how about this one? let's say this is 50 and this is 48. How long would that side be? And it's a right triangle, by the way. It has to be a right triangle. 50, 48. Do you see a triple over there that has 50 and 48? If not, then you have to try to reduce it and then remultiply it back again. 50, 48. Maybe this would help if I got you. Feel free to write it on your paper. What number goes into 50 and 48? Maybe count them over again. Your answer then you ended up with actually is 14, I believe is correct. And one last one here. How about a oh boy, not that one. How about a 63, 280 something triangle? 63, 280 something triangle. You get something from there yet? Oh, it always falls apart at the 63, 280 triangles. Toughest thing would be to think what goes into 63 and 280 that you can't do too.
Gosh, this is hard. Heaven forbid we write something down.
Bailey Lincoln. I'm sorry, 41 is not the right answer. It's the base triangle, but you have to give me what the actual triangle would be.
Oh, okay.
How about that?
It's, it would be, yeah. Oh, wow.
Oh.
Sorry.
You divide both of these by 7. This is a 940. 940. This is 41, which is what Bailey got, but you got to remember that's the base triangle. You have to go back to the original, multiply it, remultiply it by 7, take it back up there.